Okay, good morning. Welcome to
FamilyMath515a.
515a, sorry. Quite aligned, right? Alright, good enough. So I learned a pretty cool thing from John Cook from his blog yesterday. And it's a new proof, new to me anyway, proof that the Fibonacci numbers can be used to produce a proof that the prime numbers are infinite.
Cool.
And it uses a really cool fact from the Fibonacci numbers. So the greatest common divisor of Fibonacci n and Fibonacci m equals the Fibonacci number of the greatest common divisor of n and m. So, first of all, what does greatest common divisor mean?
So it's the biggest, basically the biggest number that you can multiply by something and get, multiply by a positive integer and get both numbers.
Okay.
Not necessarily the same positive integer.
What's a different way to describe the greatest common divisor?
Well, you have, the greatest common divisor of two numbers is the largest factor that is the largest number that's a factor of both of them.
Yeah. So okay, so there's two very good ways of thinking about it. So it's basically the largest number that divides into both numbers, or the largest integer. If we want to be careful. And the only thing we got to be extra careful about when we're using this formula is the labeling of the Fibonacci numbers. So I'm going to label Fibonacci number 1 to be 1, Fibonacci 2 to be 1, Fibonacci 3 to be 2, Fibonacci 4 would be
3,
Fibonacci 5,
it's 5,
Fibonacci 6,
8,
Fibonacci 7,
13,
Fibonacci 8.
it's
21.
Okay. So I'd like you to pick two numbers for me so we can just see if this formula appears to work, at least for small numbers.
How about Fibonacci number 6 and Fibonacci number 7?
Fibonacci 6 and Fibonacci 7. So our formula should say the greatest common divisor of Fibonacci 6 and Fibonacci 7 should be the Fibonacci number of the greatest common divisor of 6 and 7. Alright? So Fibonacci 6 is 8. Fibonacci 7 is 13. What is the greatest common divisor of 8 and 13?
1. Because 13 is prime.
So this side is 1. The Fibonacci number, well, does 1 equal the Fibonacci number of the greatest common divisor of 6 and 7?
It's also 1. So yes, it does.
Okay. Equal F1? Yep, sure does. Give me two more.
How about Fibonacci number 4 and Fibonacci number 8?
Fibonacci 4 and Fibonacci 8. Oh, that'll be an exciting one. Fibonacci 4 and Fibonacci 8. So what is Fibonacci 4?
So it's Fibonacci 4 is 3.
3.
Fibonacci 8 is 21.
21. So what is the greatest common divisor? Can you tell me the greatest common divisor of 3 and 21? So this should say 3 is the Fibonacci number of the greatest common divisor of 8 and 4.
8 and 4, that's 4. Fibonacci 4 is 3.
Does 3 equal Fibonacci number 4?
Yeah.
Yes, it does.
Okay. Now, have we proved this fact completely?
No.
No, we've just checked a few examples. And we're not going to prove it, we're just going to accept that it's the case. But it's a pretty cool fact.
Yeah.
Even for numbers that are going to be much more difficult for us to calculate. Perhaps for the third part of this movie we're going to go up to the computer anyway. Maybe we'll check a few higher Fibonacci numbers. Okay?
Alright.
Alright, now on to the prime proof.